Silicon carbide nanoparticles oxidize at high temperatures, creating bonds between carbon atoms, forming a connected structure. Here, the color represents the atomic mass unit of the various structures of connected carbon. From 200 to 400 picoseconds, the system builds momentum as the size of the connected carbon structure grows. Percolation, where the majority of the carbon atoms are connected, begins at around 400 picoseconds. Here, we see the connected carbon structure caused by the oxidation. One application of this process is in the self-healing of cracks in brittle ceramics, increasing the lifetime of structural composites, such as those used in turbine blades and high-temperature environments of power plants. The connected carbon structure continues to grow through the end of the simulation, which consumed about 236 million total compute hours, using over 750,000 cores of Mira, the IBM Blue Gene Q supercomputer at Argonne National Laboratory.